Now let's understand how we can use the simple concept of a histogram or a probability density function to do something called univariate analysis. So univariate, as the name suggests, means one variable analysis, right? Suppose, imagine if I have a question which is, which of my four variables, I have four variables, right? I have sepal length, sepal width, petal length, and petal width. Now I want to understand which of these four variables is more useful than other variables to distinguish my setosa, versicolor, and virginica flowers. Imagine that's the question that I want to answer. And we can answer that question using simple univariate analysis using probability density functions or histograms. Let's see how to do it. So first what I've done here is here is basically your histogram on petal length. So the x-axis here is petal length. The y-axis here is basically your histogram. Now if you notice in this, so what I've done here is I've drawn the histogram on petal length. I've also drawn a histogram on petal width. I've drawn one histogram on sepal length. I've drawn a histogram of sepal width. For all the three classes that we have three types of flowers, right? Which means we have three classes: setosa, versicolor, virginica, right? Now let's go and see which of the four variables is more useful in classifying a given flower into setosa, versicolor, and virginica. If I have to pick just one feature, which of the four is most useful? Let's try to understand that. Now let's assume if I pick petal length, from these distributions I know that I will not find a setosa flower beyond a value of 2 because my whole distribution is here, right? Similarly, I do see that, so which means my setosa is well separated from my virginica and versicolor. That's the first thing. And between versicolor and virginica, there is some separation, right? Because the overlap is only this much, isn't it? The overlap is there. We can't run away from it. But it's, so what would have been the perfect case? The perfect case would have been that I have all of my setosa here, my versicolor here, and my virginica here. If all three of them were well separated, that would have been the best case. But that's okay. What I have here is fairly good, right? I have some overlap here. Now let's see what this is. This is when I use petal length as my feature. Now let's see what happens when I have petal width. When I see petal width, I do notice that petal width, right? Okay, these two are just intersecting. So my setosa is fairly well separated from virginica and versicolor, but there is a small intersection. So the rule of thumb here, or the mathematical foundation here, is the farther these distributions are, the better, right? So the farther these distributions are, the more well separated. This is called the separation, right? The more well separated it is, the better they are. Now, if you compare your petal width with petal length, as compared in petal length, your whole setosa was very well separated. Your whole setosa was very well separated from versicolor and virginica. Here there is a small intersection here, and there is of course some overlap here. But if you look at this is almost as good as your this overlap is almost roughly the same amount as you would find in your petal length. Roughly. Of course, I'm not counting here, but roughly, right? But if I choose between petal length and petal width, see, petal length, there is there is a small tail here, and this tail is longer. So if I have to pick between petal length and petal width, I would probably pick petal length because at least setosa is very well separated from my versicolor and virginica. Now let's go and look at what happens if you use sepal length. Wow, this is scary. So if you look at sepal length, if you look at the histograms of sepal length, oh, there is massive overlap. Your setosa itself is not well separated from virginica and versicolor. There is this much overlap between your setosa and versicolor, and there is also overlap between your setosa and virginica, which is this, right? So the closer these distributions are, the more overlapping these distributions are. And if you look at versicolor and virginica, the overlap is massive, right? This is your versicolor, this is your virginica, and the overlap is this whole region, which is massive amount of region. So sepal length, if I have to pick, so till now my petal length was slightly better than my petal width. My petal width is certainly much better than my sepal length, right? Now let's go and look at sepal width. Okay, when I go and look at sepal width, wow, this is really bad, because if you look at it, my setosa is here. If you look at my virginica and versicolor are fully overlapping. This is the whole region of overlap. Like they're literally on top of each other, right? Which means it's a terrible situation to be in. Even your setosa is not well separated from your virginica and versicolor. So by just looking at these four histograms or four PDFs, my conclusion would be that petal length is slightly better than your petal width, and petal width is significantly better than your sepal length, and sepal length is also significantly better than your sepal width. So if I have to pick one feature, I would pick petal length. If I have to pick two features, I'll probably pick petal length and petal width. Of course, when I have to pick two features, I also look at pair plots that we saw earlier, right? To choose which two features are most useful in separating one type of flowers from the other type of flowers.